Latent heat is defined as the amount of heat required to convert unit mass of substance from one state to other at constant temperature. So the very important thing is this happens at constant temperature. So at constant temperature, amount of heat required to convert unit mass of substance from one state to other, it could be solid to liquid or liquid to gas, is called as latent heat. So why the temperature is constant is first point that I want to address, right? So during the change of state, if a substance has to change its state, so if a solid has to become liquid, molecules has to become loose, the force of attraction has to be reduced. During the change of state, material or the substance need a lot of energy and attention. So what all the energy that is used to increase the distance between the molecules, make them loose so that solid can become a liquid or liquid can become a gas. So no energy is available to rise the temperature. That's why the temperature was constant during the change of the state. So latent heat is defined as amount of heat energy required to convert unit mass of substance from one state to other. So if I have to write a unit, dq is the heat energy joule by mass is in kilogram. So its unit is joule per kilogram. From here I can write dq equal to ml. So whenever there is a change of the state, heat energy emitted or absorbed must be equal to ml. Right? Whereas in the case of specific heat, we have defined as an amount of heat required to convert unit mass of substance to rise the temperature of unit mass of substance by 1 degree centigrade is called specific heat. From this dq I can write ms dt. So I want you to tell you that these two formulas are very important. This one is basing on definition of latent heat. This one is basing on the definition of specific heat. So the amount of the heat energy lost or gained during the change of temperature, we shall use this formula. Amount of the heat energy required to change the state, we shall use this formula. Right? Let's go back to latent heat. We are more intended to talk about latent heat here. So latent heat of, say for example, of ICSE, that means amount of the heat required to convert 1 gram of ice at constant temperature into water is 80 calorie per gram. Means what? To convert 1 gram of ice into water at constant temperature, this happens at 0 degree centigrade. This temperature is called melting point of ice. So latent heat of ice is defined as amount of heat required, that is of course 80 calories, to convert 1 gram of ice into water at 0 degree centigrade. So if we have to say convert that, latent heat of ice is 80 calorie per gram. It's not SI system. If you want it in SI system, 80, 1 calorie is approximately 4.2 joule by 1 gram is 10 power minus 3 kilogram. So 80 into 4.2 into 10 power plus 3 joule per kilogram. So that's a conversion factor. Any value in calorie per gram multiplied by 4200 to get that value into SI system. That's called latent heat of ice. Yeah. Let's continue this discussion further. Suppose we want to talk about latent heat of steam. What's the meaning of this is amount of the heat required to convert 1 gram of water into steam at constant temperature. Of course, For water, that constant temperature is 100 degrees centigrade. This temperature is also called as boiling point. Is called latent heat of ice, so latent heat of steam. That is equal to 540 calorie per gram. So I'm defining that once again for you. Amount of heat required to convert 1 gram unit mass of water into steam or 1 gram of water into steam at constant temperature of 100 degrees centigrade is called latent heat of steam. That is 540 calorie per gram. If we have to convert that 540, 1 calorie is 4.2 joule, 1 gram is 10 power minus 3 kilogram. So that is 540 into 4200 joule per kilogram. I want you to observe one thing little carefully. Latent heat of steam is much greater than latent heat of ice. This is 540 latent heat of steam is. Yeah. Whereas latent heat of ice is just 80 calorie per gram. Why this is that much higher? If you want to observe a little carefully, the point is here the substance is converting from liquid to gas, whereas here the liquid is converting from solid to liquid. I want to tell you that converting a material liquid to gas is much more difficult, need much more energy, heat energy than solid to liquid. Why? Make the solid little loose, it will become a liquid. But make the liquid little loose, it's not going to become gas, because in the case of liquid, between the molecules there is a force of attraction. In the case of gas, the force of attraction between them is almost negligible. That means the distance or the separation between the molecules. So if you say this is a solid, make it little loose, it becomes liquid. This happens at 0 degree centigrade. In the case of ice, 80 calorie per gram. Just lose them. Now to make it gas, one molecule is here. Other molecule need not be on the screen itself. It is too large. So if the separation between them is almost infinite, occupies all the space. So they go too far to each other. To push them too far to each other, it needs a lot more energy. That's why latent heat of steam is much more than latent heat of ice. So that's what's the main point that I want you to understand here. So these two formulas are very important for you. We will be using them while we are solving the problems further. Thank you for watching.